Hello friends, welcome to my channel TECHLTEWORLD. So our today's topic will be LT handover. So we'll go through the handover concept and a few logs related to handover. So let's start the topic LT handover. So we can see this handover can be categorized on a two different aspect. So first we can see the categorization of the handover. This is basically when the EPC entities are changed or not. Based on this, it has been categorized on a three kind. So you can see the first one is intra-LT handover, inter-LT handover, and inter-RAT handover. So these are the three categorization based on EPC entities, whether it's changing or not. And the second categorization that is based on the entities that are involved or not. There is no such word like changed. Here it is the involvement. It is the APC entities like MME, PTW that are involved or not. So based on that, it has been categorized on like X2 and S1 handover. So we will go deep on X2 and S1 handover, how exactly it works. So basic concept of X2 and S1 handover selection, that how this X2 and S1 handover got selected. So first, need to check whether there is a X2 connection or not. So if there will be the X2 present, then first of all it will check that is handover is allowed with that or not. So previously, if you'll check for the X2 whether X2 present or not, and if it is not present, and like if there is no X2, then it will go for S1 handover. And the second, if X2 is present and if the handover is allowed or not. If not, then again it will go for S1. And if the handover will be allowed, then is HO preparation successful or not? If the handover preparation will be get successful, then yes, it will go for the X2 handover. And if not, then it will go for S1. So here there are 2 points which I have mentioned. Like S1 handover is when the X2 procedure fails, as we have seen. So that will be due to unreachability or error response, or there are many other options. And second thing, the MME and the SGW are involved during this handover process when S1 will be there, S1 handover process will be there. So these are the main aspects, that when X2 will become in picture and when S1 will become in picture. So we will go more deeper for this. So see, there's one pictorial diagram showing before handover scenario and in preparation, in execution, and in completion. So what basically uh, happened? So you can see before preparation, like already U is connected to the source in node B, and that which is connected to the S gateway. And till now there is no any connection, no any relation with the target node B. So now when the handover preparation will start, so we can see in handover preparation while UA is moving towards target node B. So source in node B will make the handover decision first thing. And one more thing will be there, that direct tunnel setup, that is X2 transport bearer between the source and the target node B will be created. So X2 will be created between the source and the target while this is moving in preparation. And when there will be the X2 execution, handover execution, sorry, when there will be the handover execution, then you can see this bearer will be there between source and target node B, and till now it is not fully handover. So here what exactly happening, that it is detached from the source node, be first point. And second, the packet forwarding is being done here, that you can say DL traffic from the source node B to the target node B. And in handover completion, we can see like there will be the S1 signaling through MME. This is, though we can see like path switch between the target in node B and MME is done here. And it will release S1 bearer from the source in node B. And third, like release X2, that also will be get dislinked. And now you can see our UV is connected to target node B. So now the handover process has been completed. So this we can see, and this is the basic you can say diagram where explaining that how exactly this handover process occur. So in next we can see the call flow of handover, like X2 and SN handover call flow. Both I have put parallelly because there is no much more difference between X2 and S1, or the process is almost same. In X2 the two in node B will be involved, and in S1 there will be the role of MME. So if I'm going to explain X2 in a very in a deep, and so that you can relate the S1 handover also. So first thing, there are three major things that we need to focus for the measurement, which is related to the RC configuration message. That is measurement object ID, report config ID, and measurement ID. I will show you the logs for this three also. And the last, that C, that is measurement ID. This is a combination of the measurement object ID and report config ID. So I will explain. And this measurement control. So the first message that we are seeing, that is from the source in node B to the target node B, source node B to the UV. It will send the measurement control, RRC measurement control. So measurement control, basically it is the periodic, either it will be periodic or triggered by the network, or it can be the event based. Both can be possibilities. And after sending the measurement control, the UV will send the measurement report, and then there will be X2 AP, that is resource status request, and the response will be there. And then through X2 AP, handover request will go. So we can see that what are the information that will go on a handover request. And the other message that will go from the target node B to the source node B, that is handover request acknowledgement. After that, there will the RRC reconfiguration request will be there. And then source node B will in between source node B and target node B, there will be the SN, uh, there will be the SN status transfer. And in between the the RAG process will be there. And after that you will uh, there will be RRC reconfiguration complete, sent by the UV to the target node B. And then target node B, from the target node B to MME, there will be the path switch request, which is through S1 AP. And through GTP protocol, it will be like modify bearer request will be sent to the signaling gateway. And we will get then signaling gateway will send the response to MME, the modify bearer response. And there will be the path switch request acknowledgement from MME to the target node B. And then the user packet data for the downlink and uplink will be set up from UV to signaling gateway. And lastly, the X2 AP, through X2 AP, UV context release message will be go from target node B to source node B. So like similar way, we have a call flow for the S1. So all the terms are almost same. You just go, only the entity will change. So now we will go in a deep with the X2 handover. by message, through message by message. And before that we will go to these three terms, that what are the informations that we will get in the this three RRC reconfiguration messages, that is measurement object ID, report config ID, and measurement ID. So you can see measurement object ID. In this, the information, main information that we'll get about like carrier frequency, and you can say the miss bandwidth information will be there, and miss object to add mode list, and this miss object ID will contain major information that is containing by this is carrier frequency. So and after that we have a report config ID. So report config ID will contain the event. So which event is going to trigger? Like you can see the event type A3, A3 event, A3, and the offset will be there. Hysteresis detail, time to trigger detail will be there. Trigger quantity will be there. Maximum reporting cell. These are the information that is that we will find in report config ID. And then we have a miss id. Already I have told you the miss id, that is measurement id, is the combination of the measurement report, measurement object id, and report config id. So you can see like there will be miss object id will be like 2 3 4, it will be like max up to in a system it is like 10, I have seen like they put as a count. So it will start measuring and it will be adding like miss id 1, miss id 2, like that. So you can see miss id 1, it is a combination of miss object id and report config id. So like that, miss object id add mode, then miss object id 2 will be there. Here also you can see the miss object id and report config id. And after that there will be a measurement gap configuration, which is having gp0 having a 30 value, gap offset having already we can see gp0, and which is having the 30 value. We will see about the measurement gap and this gp0 and gp1 in brief. So now let's go to the x2 handover messages in detail. So here already we have seen the measurement and that's this measurement related messages. Now when we have a x2 handover request, when we have a handover request through x2 AP, so what are the messages will be there? Contents will be there. So we can see when there will be x2 handover request, then what are the you can say I's, information elements, you can say. So we have a old enode b or old enb ue x2 API ID will be there, and there will be a what is the cause. So cause like handover is required for due to what reason, so that cause will be there. And there will be the target cell id in which we can find the plmn identity or utron cell identifier will be there. And after that we will get the GUTI information also, where we will get the mme code, mme group id. And then we will get the information about the ue context information. So ue context information will contain mme ue s1 api id, ue security capability, as security, like keys of the inode be that all the information we will get in ue context information. And after that there will be erab, the erabs to be set up. So before a handover, the source having the erabs running, erabs like erab 0 1 2 3, like 4 5 erabs will be might be running. So that list will be there. So uh, 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 that list will be there, which is having their erab ids, and they're having the qos parameters. So through which we will get the QCI. So these are the information elements which will be contained by this ERAP to be setup list. In this we will get these informations. So after that, after this X2 API handover request, which is sent by source in node B to the target node B. So we will get this much of information. And after that, the target node B will send the X2 AP handover request acknowledge. So acknowledgement we can say. So in this, the information elements that we'll find like old inode B UV X2 API ID, and after that we will get the new inode B UV X2 API ID, and then we have a ERAB admitted list. So admitted list, we can say it will having the number of means after acknowledgement that this much of ERAB can be added, item can be added. So it will be like 0 1 2 in numbers, in which we will get the ERAB ID also that already I have discussed. GTP ID will be there. So this will be for like download for and for the upload. And then we will have a X2 AP SN status transfer. Already I have you can we can go through this SN status transfer, that is between source to the target node B. So we will see what are the information elements will be there. So this will contain the old inode B UV X2 API ID and the new inode B UV X2 API ID. So both the information this is SN status transfer will having, and it will having the ERAB that is subjected to the status transfer. Means what are the ERAB is going to be transferred between the source node B to target on node B finally. That information will be there. So this will also in be like this will also be in count like 0 ERAB subject to status transfer 1 2 3 to up to n minus 1 number, and in which the ERAB subject ID will carry like ERAB ID will be there, and it will having the information of PDCP SN sequence number and HFN for both UL count value and for the DL count. So for both it will be having the information, and this is basically this SN transfer status. So here this is basically required. This field is basically needed to continuing the ciphering and the integrity protection after the after the handover. So after this X2 status transfer, we will have S1 AP path switch request. You can see here now S1 AP path switch request will be there. That is in between target node B to MME. So if we can see the information elements which are present in this. So inode B UV S1 API ID will be there now because this is between the target node B and towards the MME. So S1 API ID will be there, and ERAB to be switched DL list. So what are the ERABs that is going to be added for the DL list? That will be going to be added here, and that contains their as usual ERAB ID and GTP tunnel ID will be there, and there will be use security capabilities also will be there. In this we will have the encryption algorithm, integrity protection algorithm. So this will be containing in this use security capability. Now after this we will have MME towards MME to signaling gateway will have the modify bearer request. So this will be containing bearer context to be updated and the TEID. So the bearer context to be updated, that is EPS bearer ID will be there, and S1U enode B TEID will be there, which is included by this bearer context to be updated. and in the response, it signaling gateway will send to mme that modify bearer response, which contains the bearer context updated. Previously it was to be updated, and now in response it is updated with which having TEID. So in this we will get the EPS bearer ID in the bearer context updated, and previously it was S1U node B TEID. Now it will be S1 SGW TEID, because this is going from SGW to MME. And after that we will have the path switch. So S1 AP path switch acknowledgement will be there. So we can see here path switch request previously, now the acknowledgement will be there. So in acknowledgement, what are the things we will be getting? That is MME UV S1 API ID, eNode B UV S1 API ID, EREP to be switched in a UL list, and the security context. So these are the things that we will going to be get here. So, and after that the X2 AP UV context release message. So this is from target to source in node B. That old inode B UV X2 API ID will be there, and there will be a new inode B UV X2 API ID release in this release message. So these are the information elements which are carrying throughout this call flow. And after that there will be you can say tracking area update request will be there. So this is after the completion of the handover. So tracking area request will be there, and after that the tracking area update accept message will get. But you can see up to UV context release we have the major information elements to look out. So we have covered up to this. So now the one topic which was left, that is measurement gap. So what exactly the measurement gap is? So measurement gap is introduced to measure the different frequency of the neighbor cell and the internet from the current cell in that mentioned gap. So there must be a gap to so that the all the frequency never frequencies and the never frequency with the reference to the current cell can be measured. So here we can see by line. So when the neighboring inter frequency cell has a better signal than the serving cell, then the UV will measure the RSRP in that particular gap and inform the current cell in the measurement report. So in measurement report it will be measuring that for the better to the you can say whenever the cell is getting towards a poor RSRP, it will keep measuring and sending the reports. So during this gap UV will not listen or transmit to or from the serving cell. So that's why this gap is created for the measurement purpose. So ultimately what will happen, ultimately the network makes the decision, but the gap provide the UV a sufficient time to change the frequency, make a measurement, and switch back to the active channel. So this is basically the interval, the TTI, which we can say, in which it will take the three major thing. UV will get the three major decisions for changing the frequency, make the measurement, and then back to the active state. And so there are basically two profiles for this measurement GP0 and GP1. So the one liner I have only put, there is no, I have not put much more detail on this. So you can go through this, or if I'll get the time I will dig down on this. So GP0 is for the fast moving traffic, as its periodicity is 40 ms, and GP1 is for the slow moving, as its periodicity is 80 ms. Like small cell applications, this GP1 can be used. So this is basically the small you can say briefing about the measurement gap. So for as of now, I have tried to cover maximum of the related topics in this handover. So if you have anything to add or to be edited, so you can ping me, or you can write it in a comment. So if any additional points I need to add, or if you have any additional information that can be added, so please add that information. That is also beneficial for me and for all the guys who are going through the video. So please keep learning, keep sharing, and please motivating me and others, so that everyone can learn and can grow. So thanks for today, and please go through the topic, and if anything, please let me know. Thanks.